Hello, and thank you for joining Johnson Controls for this presentation on Building Electrification 101 and the impacts it will have on HVAC systems. My name is Mark Lessons, and I'm the Senior Director for Sustainability and Regulatory Affairs at Johnson Controls. I'm a certified energy manager and member of AHR, and I have over 10 years of experience working on energy efficiency and building decarbonization strategies. Let's talk about today's objectives. First, we're going to review the shifting market for furnaces and heat pumps. Next, we're going to grasp a basic understanding of building electrification and the impacts it will have on HVAC products. And finally, we're going to discuss the future of HVAC in buildings as they relate to building decarbonization policy. So to start, in front of you is a chart that shows the market for heat pumps and furnaces from 2005 to 2019. You can see that really over the last 15 years, we've seen a shift in the market from one that's been dominated by furnaces in the United States to one where heat pumps are almost at equal footing or have almost the same market share as furnaces. There have been a lot of reasons for this shift in market, but building decarbonization has been one of them, and we really expect that decarbonization is going to accelerate this trend. Before jumping into building electrification, it's important to understand how the building sector has decarbonized to date. It's really followed two macro level approaches. The first has been energy efficiency, which has had a direct impact on emissions from the building sector. We've seen improved building designs as well as system designs, as well as advancements in appliance and equipment efficiency standards that have really driven operational efficiencies inside of buildings to a point where they've made significant gains in the overall efficiency and reduction in emissions from buildings. In addition to that, we've seen uptake of building automation and control systems and other optimization approaches that have really helped pull through system efficiencies inside of buildings and again further reduce the overall emissions that they're responsible for. In addition to energy efficiency, we've seen really a decarbonization of the electric sector, or the greening of the grid, or clean grid, if you'd like to call it that, which has an indirect impact on the emissions from the building sector. Carbon dioxide emissions from electricity generation are down about a third since 2005, despite the fact that we've actually increased the amount of electricity that we generate year over year. This is really important to buildings because buildings consume roughly 3/4 of the overall electricity that gets generated on the grid. It's also important to understand the electric power sector and how it will continue to decarbonize in the context of overall building decarbonization strategies. At left are two pie charts, the first showing U.S. electricity consumption by source in 2005, and the second a comparison for 2019. As you can see, coal has been considerably displaced, mostly by natural gas, but you can also start to see the impact of renewables, notably solar and wind, also coming online and starting to take up a significant portion of the overall electricity mix. The combination of these renewable electricity generation sources, as well as gas displacing coal, has really led to a significant reduction in the overall emissions per kilowatt hour of electricity generated. So where are things going? It's really helpful to look at global installed capacity mix and projections for it, which is a little bit different from consumption by source, but a better indicator of where things are headed. At the chart on the right, again, looking at the 2019 installed capacity, you can really see the predominance of, again, coal and gas on the electric grid. But as we shift toward 2050, most projections would suggest dramatic increase in overall generation capacity from solar and wind, as well as other clean energy generation sources, which will lead to a much deeper decarbonization of the electric grid. So we've talked a little bit about energy efficiency and the clean grid and the role that they've played in building decarbonization. These two strategies will continue to play an important role, but next we'd like to talk about building electrification. When we say building electrification, we're generally implying the shift from fossil fuel combustion over to electric end uses. Generally, this means electrification of space heating, water heating, and cooking end uses inside of buildings. The rest of this presentation will focus mostly on electrification as a space heating sector. So when we talk about electrification of space heating, this will have a significant impact on the overall heating and cooling sector and the types of solutions that we provide. For Johnson Controls, heat pumps are really core to this strategy. To start, we've seen a considerable uptick in interest in cold climate heat pumps, as well as ultimately market penetration of these products. Cold climate heat pumps optimize their performance for heating as opposed to cooling, and generally speaking, have a COP of 1.75 at 5 degrees Fahrenheit ambient. We're also starting to see new programs that start to place additional prescriptive requirements on energy efficiency at colder ambients, as well as heating capacity. And the ambient temperatures that these requirements are starting to be seen at are also starting to hit below 5 degrees and start to look at even colder temperatures. In addition to, and really in combination with cold climate heat pumps, are dual fuel heat pumps. Dual fuel heat pumps, again, utilize a heat pump as the primary heating load and can play a significant role in decarbonizing the overall heating that's used by a building. Unlike all electric heat pumps, dual fuel heat pumps utilize fuel combustion as a backup heating system only, and thus are a little bit more flexible in their application. They're also going to play an important role as a transition technology as we decarbonize all of the end uses of our economy. Next are water source and ground source heat pumps, again in the DX family, and we expect continued growth of these types of products. Water source and ground source heat pumps don't actually rely on air temperature to boost their efficiency, so they can be ideal for applications in colder climates as well. Also, variable refrigerant flow, or VRF, is going to continue to be an important system that is used to decarbonize heating. VRF heat pumps are often available in cold climate capable technologies as well, and so they, in many applications, are ideal for decarbonizing heating. Shifting to hydronic systems, we usually think about chillers as only providing space cooling, making cold water that's distributed throughout the building. However, they can also come in heat pump chillers. Air-to-water heat pumps utilize changes in air temperature to boost the efficiency of the hydronic heating process, much like it does for cooling. And so these types of systems can start to displace and ultimately replace fossil fuel fired boilers as an electrification and decarbonization strategy. In addition to air-to-water heat pumps, we can also start to deploy water-to-water heat pumps. These tend to be a little bit more complicated in terms of application and design than air-to-water heat pumps because they rely on a ground source or water source or another heat source for additional heat exchange, but they can also tend to be yield a significant improvement in overall energy efficiency. Both air-to-water heat pumps and water-to-water heat pumps are going to be critical for commercial and more complex industrial applications to really boost electrification and decarbonization of heating. In addition to equipment, controls are also going to play a very important role in enabling even deeper decarbonization. Whether we're talking about thermostats or sensors or building automation and control systems, these systems are going to be critical in optimizing loads and helping to manage the increased electric demands that we're going to start to see that are driven to the grid by building and other decarbonization approaches. Sensors and controls can really help to optimize loads and make sure that we manage these loads effectively, boosting efficiency while also maintaining grid resiliency, as they can enable communication between the equipment and the grid or the building and the grid. So when we start to talk about electrification, it's important to understand the concept of beneficial electrification. This is a term that was really coined by the Regulatory Assistance Project a number of years ago, and it's an important definition that I'll read now. An electrified end use must satisfy at least one of the following conditions without adversely affecting the other two. Saves consumers money over the long run, enables better grid management, and reduces negative environmental impacts. So what does this mean when we actually start considering various building electrification measures? First, they need to be cost effective. So they need to take a look at the upfront cost of the appliance, as well as current and future costs of electricity, as well as the incumbent fuels like natural gas or propane or fuel oil. Doing a full life cycle cost effectiveness calculation will help ensure that we deliver cost-effective solutions to our customers to maximize decarbonization. Next, we talked a little bit about grid management on the previous slide. Grid management is going to continue to be a critical portion of beneficial electrification. As we electrify more and more end uses, the load profiles that the grid start to see will start to shift. And if not managed properly, we can start to see increases in overall peak demands. The ability to manage and optimize loads is going to be critical and a critical component of electrification measures to make sure that we maintain a resilient grid and ultimately have a system of buildings and other electrified end uses that work in concert with the overall electric grid. And finally, the environmental impacts. We have to take a look at the current and future emissions intensity of the electric grid and compare that to the emissions intensity of natural gas, propane, and fuel oil for the life of an electrification measure. Having good visibility into where the grid is headed, especially by location, can help enable an accurate comparison between the emissions intensity of two different heating strategies and ultimately provide a clear result and help ensure that the solutions that we deploy for electrification are beneficial. Focusing a little bit on policy, we've seen quite a bit of activity both in California and in New York and New England that are really trying to drive building decarbonization through strategies for electrification. These policies tend to focus on 4 different areas: utility incentives, state policies, state funding, and gas infrastructure. And there's really a lot of similarities between the strategies of California and New England in all of these categories. First, we've seen utility incentives for heat pumps. In California, most of the heat pump incentives have focused on general or moderate climate heat pumps, given that they have a bit more balance in demand between heating and cooling. In New York and New England, we've seen very aggressive incentives offered for cold climate heat pumps, which really help break down the upfront cost of that equipment and drive greater market penetration. Next, we've seen state policies that are driving electrification and decarbonization of the building sector. In California, there's in legislation statutory requirements for building decarbonization to be achieved at certain milestones. In New York and New England, it's most every state has a plan for decarbonization statewide, and these states have also started to develop roadmaps for how they will achieve their the level of decarbonization that they're targeting. Buildings are often looked at in these roadmaps, and often building electrification becomes a core component of these strategies to get to net zero, often by 2050 in these states. Additionally, these states and state agencies are providing funding really focused on research and development for building decarbonization. In New York and New England in particular, funding has become available to really try to boost and accelerate the performance and market penetration of cold climate heat pumps. Where we start to see a little bit of differentiation is in the thinking about the future of gas infrastructure. In California, notably, roughly 50 cities have passed municipal bans on gas infrastructure in new buildings. The building codes effectively prohibit the extension of the natural gas pipeline or infrastructure into these buildings, thus more or less requiring that they be all electric. In New York and New England, we've seen some of those similar municipal bans, but we've also started to see approaches from the Utility and the Public Utility Commission as well. In New York and New England, we've seen individual utilities self-impose moratoriums on extensions to the gas infrastructure, and we've also seen PUCs in their rate-making processes for natural gas utilities start to require ramp downs or even eliminations of new gas hookups, and also that these utilities start to educate their consumers on electrification options that they have. All of these policies are really targeted at boosting electrification as a core decarbonization strategy. So I'd like to take a few minutes to focus a little bit on what Johnson Controls is working on as this market shifts toward decarbonization. First, we talked a little bit about cold climate heat pumps, and this really requires a new way of thinking about and ultimately designing heat pumps by re-optimizing these heat pumps for their heating loads as opposed to their cooling loads. This is an area where we expect to see continued capabilities and to really respond to customer demands and market growth in the cold climate heat pump sector, and will continue to boost the performance, efficiency, and capacity for cold climate heat pumps at colder and colder temperatures. Additionally, we're working on new control algorithms and strategies that really take a look at location-based performance, trying to capture adjustments that might be necessary in overall heat pump operation based on the climate or where the heat pump might be installed to, again, really boost the overall performance of that heat pump and make sure that the customers get the best performance they possibly can out of their equipment and help them, thus also maximizing the decarbonization outcomes. And finally, expanded capabilities for applied heat pumps are also going to be extremely important and something that we're working on. We're really taking a look at expanding our portfolio of heat pump chillers to really reach more and more buildings and ultimately help reduce the load on fossil fuel combustion-based boilers with the goal of ultimately replacing and decarbonizing all of the heating end uses in those buildings. In addition to electrification, it's also important to take a look at where the building sector might be headed from a broader perspective. The U.S. Department of Energy has really spent a good time championing and leading this movement toward grid interactive efficient buildings, or GEBs. Grid interactive efficient buildings start off by being energy efficient. DOE recognizes that reducing electric and all energy loads to the greatest extent possible is the best first step to ensuring that we can decarbonize and better manage these buildings in the long run. Next, GEBs are connected. The appliances or building management systems generally can connect to other systems within the building. They can connect to vehicles, they can connect to distributed generation, and they can connect to the grid. The ability to connect and talk to one another really helps, is really going to be critical in making sure that we can enable building intelligence and ultimately optimize building loads. And that serves as a nice segue to the next component of GEBs, which is that GEBs are smart. Taking all of this connected equipment and utilizing third-party data as well as occupancy data, weather data, additional data that the building might be collecting really helps enable deeper optimization of the buildings to make sure that we're delivering the outcomes that are being expected at the most optimal outcomes possible, both for energy management and decarbonization. And last, these buildings need to be flexible. Having an understanding that buildings have building management systems that can enable shifts or sheds of building loads, as well as starting to leverage distributed energy resources, especially those like batteries or rooftop solar that might be installed as part of a building, really enables this deeper flexibility of the overall building load and helps make sure that we can respond to changes or needs of the grid, while again optimizing for the outcomes that building occupants have come to demand. All this taken together is going to enable, again, deeper decarbonization of the entire building sector. So, a few things to take away from this presentation. First, the HVAC market is starting to shift to favor heat pumps over fossil fuel combustion heating. These effects are being seen today, and we really expect this trend to continue to accelerate in response to building decarbonization. Next, electrification really needs to be combined with energy efficiency and grid modernization to maximize the benefits. And in addition to that, electrification measures need to evaluate socioeconomic factors as well as environmental impacts, again, to maximize those benefits. Doing all of that will help make sure that we deliver the best possible decarbonization outcomes while also maintaining the same expectations that customers have for what buildings and their equipment provide for them today. Also, the best solution for building decarbonization is going to vary by building application, by location, by type of grid, etc. We have lots of different solutions from a technology perspective that we can deploy to achieve deep decarbonization in buildings, and having that flexibility to choose the right solution for every building is going to be critical, and it's going to be important to understand the various options that we do have at our disposal in order to make sure we're choosing the best option for every customer in every building. And finally, the future is bright for decarbonization solutions in the building sector. If I take a step back and think about what's important to Johnson Controls and also the type of value that our customers see from us, being able to respond to this increased demand for reducing carbon emissions and ultimately decarbonization as a whole, this gives us another thing that we can provide to our customers. And this is really an industry-wide solution here. Being able to have the solutions that deliver on our customers' needs for building decarbonization increases the value prop that we can all provide and ultimately puts us in even more demand and makes us even that much more valuable to our customer. So we think this is going to continue to create additional opportunities really industry-wide when it comes to addressing the future of buildings. That concludes my presentation. I hope you enjoyed it, and I look forward to connecting with you in the future. Thank you very much. Goodbye.